Hello, everybody. It's me again, Rich Andre. And today we're going to be talking about separable first order differential equations. Okay. So before we start, let's first define what differential equations are. Okay. Differential equations. What are differential equations? Let's look at s- let's ask ourselves, what do we mean by differential when we're talking about anything related to math? Well, the first thing that comes out to mind is derivatives. Okay, derivatives. So when you're looking for a derivative of something, you are differentiating an equation. Okay, you're differentiating an equation, and that's just basically what uh, differential equations are. They are equations that have derivatives in them. Okay, so there are different types of differential equations, but we're just going to focus on this type of differential equation, which is separable. Okay, and we have to specify what order the differential equations are. There are different orders. Okay, but I'm not going to talk about that. So we're just going to leave it as a separable first order differential equations, and I have here a couple of problems that we could solve in order for us to grasp how it works. Okay, so it's going to be very simple. The only thing that you need to do, okay, is you have to sort of cross multiply. Okay, so yeah, you just have to cross multiply. Okay, so you obviously, let's first start with the first problem. Okay. Okay, so I just got this integration power rule. Okay, power rule, the IPR integration power rule right here. We can use this in order to integrate these afterwards. So the differential equation we have to solve here is derivative of y with respect to x is equal to 2x over 1. Okay, so when you see that, when you see something like this, it always has a 1 below it. That's basic algebra. Okay, so now we just have to cross multiply both of these. Okay, cross multiply both of these, and you get we get dy is equal to 2x and dx. Okay, now we just have to integrate both of these. Okay, so what is the integration of dy? Well, obviously we're just going to have y. Now we have to integrate 2x. Okay, so we have to integrate 2x. So we have x right here, x plus 3. So we just have to use the IPR. Okay, so if we use that, we have x. What is the n right here? Is 2 plus 1 over 2 plus 1. Then we're going to have x3 over 3. Okay? Over 3 plus c. Okay? Now that we have this, okay? Just see this. So I'm going to be wrong on this part. We just have to get rid of this, okay? Just have to get rid of this. I'm sorry about that. I forgot that the exponent here is going to be actually the exponent. So we have x. What is the exponent of here? Well, just 1. So 1 plus 1. 2 plus c. Okay. So we have x squared over 2 plus c. But over 2 is not going to be necessary, I believe. You don't have to include that, the over 2 one, because this is the final answer for this. So let's go to the next question. Next problem that we're going to solve, which is dy derivative of y respect to x is equal to 3x squared. Okay, so cross multiply and then get the derivative, get the integral. So you have 3x squared dx. Now you have to get the integral. Okay. So then, in order to get the integral, you just have to do this. X, what is the exponent? 2 plus 1 over 2 plus 1. Which we're going to have x3 over 3. Then we have 3 over here. So that's going to cancel. You're just going to have x3 plus c. Okay, so the derivative of y, dy, the integral of dy is going to be just y. So y equals x cubed plus c. Okay, so let's see if our answer is correct. Yep, it's x cubed plus c. Okay, so let me just close these here. Sorry if I've made a few mistakes, okay, here and there. I'm also still learning this, so thank you guys for your patience. So now we're going to have dy, dx, and xy. So it's going to be here. Then xy dx. So using this, we have x plus 1, x plus 1 plus 1, 1 plus 1, that's going to be x squared over 2, then 2, x, x2, 2, and we're just going to divide, I believe. Let me just, okay. So we're going to have a little bit of a problem here. I actually asked ChatGPT to give me simple and basic questions and problems, and he gave me one of the most complicated. gave me another special case to solve. So we have dy, but I understand it now. We have d derivative of y with respect to x equals x times y. You're going to have to times both of them, okay, cross multiply. So you have dy equals x xy dx, and then you get the you integrate both of them. Then you're gonna have y equals, okay, now you're actually going to divide both of them with y. I believe that is, okay. So you have to divide both sides by y. Yeah. Then hold on. Hold on. You have to integrate them first. Yeah, integrate them first. You get y equals x. You have to use this, I believe. N plus 1. That's going to be 1 x squared 2. And then plus. Wait. Let me just Let me just make sure I'm doing this right. Ah, I see. So I was right. I have to divide both sides by y first before you start doing anything. So we have 1 over dy. Is that it? I believe that's it. No, 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 no. You have to divide it like this. Y, dy, and then since both these cancel, you have x dx. Okay. So now, since we have this, now you have to integrate it. After you integrate it, 1 over y is going to be the integration of 1 of x. 1 over x is going to be always ln, and then the variable, the absolute value of the variable. So that's going to be the natural logarithm of y, and then we're going to have, I believe, this. Yeah, so that's going to be ln absolute value of y plus c. Then because you integrated it, you have to add a constant. You have to add a plus c because there's a constant, and then x plus 1 plus 1. The exponent of x is going to be 1 plus 1. That's going to be x squared over 2 plus c, I believe, or Mr. dx. Yeah, yeah. You have to add another constant here. So now that we have this, we have to turn this into exponential form. Yeah, I believe you have to turn it into exponential form. Expand the expression. We have to use this. We have to use this sort of equation in order to expand this expression. A to the power of n plus n equals a raised to m times a raised to n, and now we have to sort of make the variable. Okay, make the variable of this is going to be e, and then we have x squared over 2, and we're going to have to use this same thing here to have e c to expand the expression. C is treated as a constant, so we're just going to have c here. We're just going to have c still. We have e x raised to x squared over 2, and we're going to have ln plus l logarithm ln absolute value of y plus c, and then we have to, hold on, let me just, yeah, okay. Okay, commutative property. Okay, so say use, well, now that we expanded it, this is going to turn into y, and then just the absolute value of y equals c e x squared. So using the commutative property, the c here, the hold on, the c here, okay, the constant is going to come here. So now you have this ce. I believe that's it. Okay. I don't exactly know why there is a commutative property, but since we got an absolute value, we have to treat this as two properties, as two sort of equations. So we have ce. The first equation is ce constant times e to the power of x squared over 2, and then negative ce, And now that we have that, let's suppose that y is equal to 0. Okay, let's suppose that is equal to 0. Let me just check my note. Let's check. Differentiate, simplify. D of dx. D derivative of a constant is always 0. String. Okay. So what it's basically we have to do is we take the original equation, so d this, okay, then we replace the y's, the y's. So we have d over dx equals x times 0. d oh, I forgot the function. There's going to be a function here, so we have to include the function here, 0, and x times 0 is going to be 0, and that means 0 is going to be the solution for these. Okay, that was a very long, that was very long. So now we have to go to number 4. Hopefully it's much easier. Okay, so it was 4y. We have dy over dx equals 4y, so now we have to cross multiply. We have dy is equal to 4y dx, 4y dx. Then integrate it. We have y equals y plus 1 plus 1 over 2, 4. Then we have to do this. Okay, so 4 divided by 2, this is going to be hold on. Yeah, 2y squared dx. I believe that's the answer. Let me just check. Let's check. 4. Oh. Oh, 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 oh. It never ends. This is so typical. Let me just. This is. Let me just try to solve it again. So we have this. I'll try to solve it again. I still don't understand how that worked. How I was able to solve. Number 3. Yeah, differential equation. Husband expression. Therefore, y dx by both sides. Oh, so we have a logarithm once again. Integrate both sides of the equation. 1 over y dy for dx. C. That's going to C. Okay. Okay. I think I'm trying. I'm getting it. I'm getting it now. I think I'm getting it now. So we have dy over dx. We have dy over dx. Equals 4y. So what we're going to do here is cross multiply. So we have dy equals 4y dx. Integrate. That's a radical sign, but sorry about that. Then we have to integrate. Hold on. So no. We actually have to divide both sides by y. We have to divide both sides by y. So now we have. Let me just see this. Integrate both sides. Divide both sides by y. Divide both sides by y. Then we're going to have 1 over y dy is equal to this cancels out. Now we have to integrate. Let me just. Now we have to integrate. Here's right. Integrating this. Let's see. Okay. So integrating this is going to be 4x, and then integrating this is going to be ln as absolute value of ln absolute value of y is equal to integration of 4x. It's going to be 4x dx ln y. Okay. And then plus c, you have a plus c here. We have ln y plus c equals to 4x plus c dx. So we have to expand this equation. We're gonna get y equals e 4x plus c plus e and c, and then dx. Okay. So then we're going to put that. Hold on. Let me just see if I'm correct on this. Okay, so we don't have to include c d dx at the end of the equation here. We just have absolute value of y is equal to e raised to 4x plus e raised to c. And using the commutative property, we're going to have, when we expand this, we're going to have e4x, okay? Now using the commutative property, c is going to be here. So ce 4x, y equals, okay? Now that we have the absolute value of y, so we're going to treat this as ce 4x. Now let's see, okay? Let's go back. Let's see if y equals 0 is a valid solution. Okay, so let's see if y equals 0 is a valid solution for this. Let's go back to the original equation. So we have dx equals 4 times 0, and that's going to be 0. Okay, so that's a valid solution. So our answer is going to be ce4x negative ce4x and y equals 0. That's going to be our answer. But the answer is going to be It's going to be CE for x. I think that's a good solution. So this is the general solution. This is the particular solution. You see? So now we've solved 4. Let's go to number 5. Okay. Let's go to number 5 here. Man, let's just do it. So we have dy over dx equals x over y. So we just have to do this. So dy times y, it's going to be dy goes x dx. If I'm not mistaken, let me just see the answer. Y dy. So the variable is always going to be for the first to be here. So we have y dy equals x dx. Okay. Now we have to divide both sides by y. Divide both sides by y. Let me just see the answer real quick. Okay, so we're trying to get y, okay? So if you divide both sides by y. Oh my god. You actually don't do that. I guess you don't do that because there isn't a CE or anything related to that. So you have integration x squared 2 plus c dx. Now that we've integrated that, integrate y. So we're just going to have y. And I believe that's the final answer, yeah? We have to integrate over that. Hold on. Integrate. Oh, you have to integrate this too. You have to integrate. Ah, I forgot. So for y squared over 2 plus c. This is also has a c. This also has a c in it, right? So now that we've integrated that, what do we do next? Let me just see this. Ah, you have to multiply by 2. Then divide. If you divide that, you get that. Oh my god. Oh no. So exponent isn't going to be part of that. So we have y 2 x squared plus c. That's going to be the final answer. Okay, so we're going to get number 6. Okay, we're going to go do number 6 right here. To do number 6 right here. Dy over dx equals y squared. Cross multiply, we get dy y squared dx. Integrate that. that y equals y squared by 3 over 3 dx. There we have plus c and by 3 over 3 plus c here. You multiply by 3, so this is going to be y3 you can remove the constant here because I don't think that's necessary. So you have y cubed y3 plus c d c. I think that's the correct answer. Let me just see here. Let me just. Of course. How typical. How typical. There's always going to be a special case. Uh-huh. So I'm just trying to rederive everything from the solution down. Okay. So from the answer down. Let me just take a break. And then we'll proceed to answering number 6 here. I can't really understand how they solved number 6, so how does S? What's the full solution? So number 6. Sort the variables. Makes this to the right. Integrate. Let's see why. Make it more strong. Reciprocal of both sides. Okay, so I'm just going to do it by memory. But I still don't still barely understand it. So you have dy over dx equals y squared. So we have two separate variables. We have y squared dy. We have y squared dy equals dx over here, and then integrate both of them. We have if I integrate both of them. Wait, let me just 1 over 1. Okay, so we're moving this. Before we integrate, we have to move this and make it a fraction. So we have y. I'll just use this form. So we have y over 1 to negative 1 plus to negative 2 plus 1 is negative 1 plus c, of course. Uh, Derivative of dx. Integral. Integrate. You have to integrate. What? It's the power rule. Okay. Okay, I get it now. So we have y1, negative 1 plus c equals x plus c. Then, um, simplifies to x plus c. Okay. Okay. So negative y divided by negative 1. It's gonna be negative 1, then copy. Then we have plus c. X plus c. Now we have to find and solve. We have to solve for y. So in order to solve for y, you have to make this negative, and then it's going to be c plus x. X plus c. God damn, how do you do this? X plus c. So we have 1 over y. You can just rewrite this as 1 over y. Because compose x c. Then we're gonna have c minus x 1 over y. Take the reciprocal, so there's going to be a 1 here. So we have y equals 1 over c minus x. Okay. Because we took the reciprocal, this is going to be replaced there, so we have y1. So it's just going to become y, then we have this c minus x, which that's reciprocal. So this is the answer. It's the final answer for number 6. I think I'm going to end it here. I can't really answer any more of these, otherwise my sanity will degrade. Either way, that's it for this video. Thank you guys for watching. If you liked this video, give me a thumbs up, give me a comment, give me a feedback. Thank you guys, and stay tuned for the next video.